welcome back to the channel. In today's video I'm going to do an overview of a couple of different products that I'm testing for review. And before I get started with that, I decided to do the final type of prototyping build-up. This isn't the actual prototype ones that are still getting made. I should have them before you see this video, but this is what the end design was. I just took two of the other ones that were bad and made them work. So as you can see, it neatly holds your taps and your drills. Obviously I need to get some 5/16/18 taps to fill in that little spot, but it just provides you an easy access to all your different Endmills, or not Endmills, get ahead of myself on that one, taps and drills. So like, here's your clearance tap for a 632, here's your steel drill, here's your aluminum clearance drill, and then you get 3 different taps. Now obviously my quarters are a little different than the rest because I'm testing out these two, and that's about all I have for 1/4 inch taps at the moment. So yeah, I just wanted to show that real quick. That's kind of what it looks like, and I think I will sell these at some point. Let me know in the comments if you would be interested in buying one. I don't think they'd be very expensive. I still haven't prototyped the metric one, but it's going to be very similar to this. I think I'm going to go from 3mm up to 10mm or thereabouts. Maybe a little, maybe 10/9. I'm not sure yet. I don't really use too much metric outside of 3, 4, and 6. And maybe 8mm. No, I've never used any 8mm, but I'd probably throw it in there because I can see some use for it. But that's what it looks like, and we will move on from there. I'm also going to do some collets. But today's video is talking about hybrid servo motors. What these are, it's basically a standard NEMA 23 or 34 or 42, whatever stepper that you want, and they put a servo encoder on the back to make it more accurate. What this means though is you can't use like your standard Gerbil programmer like you would right now, because you have to actually hook into a proper driver. So I've already done some pre-wiring, so I'm going to be testing it here probably later today. But so what you got is a standard servo controller, and you got your dip switches. Those print out here. That corresponds to these dip switches right here. Right now this one is, I haven't even messed with this driver yet, and let's see here, we are on, off, on. So you just read the table where it's, and you look for on, off, on, and that's 1600 pulses per revolution. Generally speaking, since I bought these as a kit, they usually preset that for you, but if it's not set right, what you do is you calculate the distance travel on your ball screw per revolution, or even with this, and you just mark it. And then what you do is you measure it and make sure that if it's supposed to be 1 revolution, if your flat is at the top perfectly 90 degrees and it ends up being canted slightly, say that way, that means you don't have enough pulses to get your full revolution. So you just got to figure out what that is. Obviously it's going to be a little more, like if you're at a 16 you really need a 32, it'd be half. So you just go down the list until you find one that matches it perfectly. Like I said, generally the way these are set up is they preset those for you, and then there's also switch 1 and switch 2. Honestly, I'm not really sure what those do. They came default in the off position, so I'm just going to leave them there. And yeah, that's about it for these. So what they do is give you, I think this is 3 meters of wire, and so for your 4 conductor, it also has the power voltage that drives this driver plus the motor that I haven't screwed in yet, but you just tie that into that one, and then that just goes into 4-pin mullets. And it does look like these are panel mountable, which is kind of nice. And then the same for the logic circuits. So I put ferrules on these because I absolutely hate using just bare wire, because when you go to take it off and reinstall it in the future, they get all chowdered up, and that's just no good. And then you just plug that into this correspondingly with the data sheet. Plug that into this side just like any other Molex, and boom, you got yourself a functional servo. And then this side right here gets hooked into your in my case it's going to be a Mach 3 breakout board. When I get done showing you this, I'm going to show you 2 subboards I designed to make my life a lot easier when using these. And when we go back inside, I'll show you that. Other things that come in the kit is they actually give you some strippers, which I thought was kind of odd, because I would figure someone that is doing this would probably already have a pair of strippers, but since they give them to me, let's take a look. It's actually a rubber handle, standard safety, and you know, for a free pair of strippers, they don't seem that bad. Honestly, like, I might actually use these. And the other thing it comes with is a power supply. I'm in America, United States, and I'm going to run this on 110 power, so before I do anything else, just grab a drill. I'm going to switch this over to 110 before I accidentally screw something up. So, you just plug in your ground, your neutral, and your hot. It does have 3 poles, so if this was a 10 amp DC, actually, where are these? These are 3 amp. Yeah. So if I had a 10 amp one of these, I'd only need 1. However, the way they sell these kits, they come with this, this, and some super high quality electrical tape, and of course the strippers that actually aren't half bad. This all together is like $100 on Amazon. I'll put a link to it in the description. To be honest, that's actually a really good deal when just getting these by themselves can be around $80. Just these 2 things without the extensions, you don't get strippers, and everyone needs a pair of wire strippers. Even if you got a few pairs, just having pairs that are like this that you can just beat up and just abuse, it's always nice to have something like that. And then a power supply. Now this is probably China's finest right here. I don't know, I'll have to have my wife look at that and tell me what it says, but the price says for silly Americans only, but that's not the point. The point is, it's not too bad. What this size power supply should be smaller, yeah. I mean, it's only a 5.5 amp power supply, so you'd think that you could probably fit one in about this size package. But they went for cheap, which, whatever, it's fine. I might end up swapping these out for a single one that has a 10 volt. Not too sure yet. We'll see how it goes. I do kind of like the idea of being able to just having one power supply fail and it doesn't just make the whole machine freak out. It's just easier to swap one out for each axis. And it also allows you to have full current available for each axis, which is nice. So if you're doing a complex 3-dimensional milling operation, you can have full power without worrying about bottlenecks within the system. And it even comes with a little voltage adjuster, which is kind of nice. So if you're not quite on your voltage, you can actually tweak that pot a little bit and clean your voltage up, which I'm imagining I'm probably going to have to do. So, as for powering this, I have a large collection of old power supplies I keep around the house because I always find projects for them. So in this case, I'm repurposing a old Xbox 360 HD DVD player power supply. Yes, I did have an HD DVD player. It was different. But it's a 12 volt, 2.5 amp power supply. The reason I have this is because my USB power driven Mach 3 controller requires a 12 volt signal, which is nice because that means, unlike some of the Gerbil boards that are running on 5 volt, I don't need to put a buck converter into my system to get my 0 to 10 volt signal to my VFD. So enough yapping out here. Let's go to the office and I will go over the actual drawings for the system, and as well as the what are those called? The breakout board drawings and my little subboards I designed. Oh, and I almost forgot. Powering the whole thing is going to be this little itty bitty computer that cost me literally nothing because I had enough Amazon credit that this $100 computer was free. And it actually blows my mind because it runs full Windows. Blows my mind. I honestly do not know how they were able to sell a computer with onboard storage, mind you. That's got 64 gigabytes of flash storage built into it. And I think it's 8 gigabytes of RAM and a 4-core 2.6 gigahertz Celeron processor. All of that plus Windows for $100 when I can't even buy a Windows license for $100. It just blows my mind. Anyways, into the house. Alright, now that we're back in the office, let's go over some of the wiring diagrams and schematics for the collection of parts that I showed you. The one part I have not shown you yet was the breakup bar itself, but the drawings here give a good idea of what it looks like. Right here's your USB port. Right there's for the MPG, and then all the drivers and the accessories all go in there. So for the x-axis, you need a 5 volt signal that goes to the positive pulse. You need a positive direction, and you need a positive enable. And then all of the negative items are tied into, or rather all the positives are tied into that 5 volt signal. And then your enable negative is tied over to here. And then everything else is kind of how I explained on that driver yesterday. Let's go down the list here. We're not using an A or a B motor, so it doesn't matter. For the E-stop, you tie into the common, along with the, I can't know if it's an L or an I think it's an I1. And then the I2 goes into the tool probe. So that's how they wire these two together, is you tie this into here and then it all goes back to a common ground circuit. And then limit switches, I haven't dealt with that yet because I haven't decided which switches I'm going to use. So the subboard that I have designed doesn't include those. That'll be on a third board that's just dedicated to limit switches. That way if I ever change them in the future, because as you can see here, you can use micro switches, NPN switches, and I think there's one other switch you can use. I guess not, it's just micros and NPNs. So I haven't decided which one I want to use yet. So the board hasn't been made because they wire in differently, so I just didn't want to deal with that yet. And then the VFD. This is important as well. This has the forward, VI, and ground. The common and ground on the VFD are actually a common pin to each other. And then there's only really 3 wires that go out because the common and ground will actually bridge together, and then one of them will be tied back into the controller, and the VI and the forward will be tied in. And then there's relays. I haven't wired any of these in as well, and those will also be on a separate board if I do make them. So let's look at the motors. Let's see if I can switch you there. Alright, that's for the accessories. So let's go over into the, I think it's this one. Yes, so this is what I designed. It's, there we go. It has all of the major schematic part. So I'm using RJ45 connectors and Cat6 wire to connect everything, so it's nice and clean, and you can pull things out as needed without having to unwire a bunch of stuff. So on the breakout board, there's a single Cat5 cable or Cat6, whatever one I decide to use, doesn't really matter. It's all interchangeable for our purposes. That has 8 pins that go to all that stuff on that one side of that breakout board. So let's see if I can switch us back real quick. And then let's see here. Alright, so everything from this 5-volt over to this enable, mind you, we're ignoring the AP, AD, and BP, BD because we're not using the A and B accesses. So there's 8 pins that go to that. That will correspond with the 8 conductors within that wire. So these all do different things. So if you follow this back, one is the common ground. That's what I use for the common ground wire, or actually this is rather the 5-volt signal. That's the common 5-volt. Then the x-axis only has a few wires. They've got, and then same with the y and the z. A lot of those wires are shared, so the +5 is shared, and then the negatives are all tied together. So those are all tied together with the +5 is the all the positives. So the direction, all the plus voltage stuff. So it seems to work out pretty good for what I'm doing. So all of the negatives get their own lead. So the pulse negative, that gets to, I believe it's this one, and the direction gets this one, and so on. So you just follow those in. Pins 4 and 5 get bridged over to pin 8, which is the positive. That's the 5-volt positive. And then pin 3 on these is all tied together to the enable pin. And so you got a +5 voltage and a enable pin, which are both effectively common to each other. And then I also tie all of the actual housings to the board ground, so there's shielding for the entire system, which is important. And then for the other side, this is for the spindle and the e-stop / probe. This one doesn't have nearly as many wires, so 7 and 8 are completely empty. But to the e-stop and probe, they just follow the common grounds, and you get that. And then same with the VFD. There's only really 3 wires going out because, in effect, I mean, there's 4 physical wires just so I don't have to bridge it on the VFD itself. But on this breakout board here, they're actually bridged together, as you can see right there. Here's a bigger view of it. So as you can see, that ground common gets tied together right here, and then only the forward and VI actually have dedicated pins to this. And in reality, this common's also a ground, but I didn't tie them together. I wanted to be isolated since they're isolated on the main board. And then this is what the 3D renders of it look like. You got your 3 connectors. Now I probably should have used through holes I don't have any through holes on these. I'm using surface mount, so it might be a little bit of a pain for me to solder, but whatever. It is what it is. And then this is the other one. And then you see all the shielding and the whole bottom side shielded, and they're not shown here, but they're part of the grounding goes through these, and you just solder it all together, and it all binds together and makes a nice package. So on to, let's see here, switch display again. Now this is the driver that we're using. So on all of those things I showed you outside, these are the two I showed you. So you got the motor coils, and then the 24 volt, in my case 36 volt power supply plugs into here. So that'll occupy those two slots, and then the motor itself takes those four. And then the encoder is that other one that I showed you with the 6-pin bundle. That's what goes here. And then these plus minus pulses, plus minus direction, and plus minus enable. This is all optically isolated. That's what those little arrows signify with the diode. That means that you don't get electrical noise in between the connections, so you get more precise movement and location. And then that's the stuff that's actually sent to and from the board. All these two are located strictly within the stepper hybrid servo by itself. Oops. And then this right here, this is what goes to the breakout board. And I'm not using the pendant and alarm on this because I don't need it. But that's what I'll show you from that one. Here's a better look of the actual card I'm using. These are pretty cheap. I got it with the MPG for like, I want to say 30 bucks. I mean, and it seems to work pretty well. These yellow pins are just duplicates of these if you wanted to use just regular push connectors. I didn't really want to deal with that. That's why I made the breakout boards. It just makes a cleaner design. And you're also having to duplicate the enable and the 5-pin plus for every single stepper, and this way I don't have to do all that, and I don't have to make any harnesses. But this is what it looks like. It's a good little reference to look at. It tells you what everything means, which is important, and it's actually quite well documented. It even gives you the wire out for the MPG, so if you want to use a different one. These use basically a VGA connector for the MPG instead of the what is it? I think it's normally like a 15-pin, but they at least tell you what each of these pins does so that you can make it work. And then that's the little MPG that they give you. It doesn't have the cool dial on it, but for basic zeroing and stuff, I think it'll do fine. I mean, it was kind of a bonus for me. And then there is a special driver for Mach 3 that you use, and it's actually pretty easy. I don't use the provided version of Mach 3 they have. I just pushed the plugins over, and it works just fine. And then when you turn it on the first time, it's got a little dialogue. You just select that, click that, and then hit OK, and you'll never see it again. And then it shows you how to set up the motors. This is probably the more important part of this manual, because if you don't set it up right, you will have problems. And then it allows you to adjust the movement acceleration. That's something that you're going to have to learn how to tune yourself, because each machine's different. And then just make sure all your configurations are correct. And for a Chinese part, this is actually really well done. There's not very much English in it, so kudos to them on that. But yep, this is pretty much it. In the next video, I'm going to show you it wired up and running. I'm just waiting for the breakout boards to actually arrive. JLC sent me an email yesterday saying that they're on the plane, so they should be here in the next couple days. and hopefully I'll get a motor moving so I can show you how that all works. So thanks for watching, and see you next time. Have a good day. Bye.